Hello, welcome to our channel. In this video, we will look at sum, difference, product, and quotient of functions. And also we will look at the domain of these combinations of functions. So given two functions, f and g, they are added, subtracted, multiplied, and divided in the usual ways. So let's look at an example. We are given function f of x equals x squared plus 1 and g of x equals 3x minus 1. So basically f plus g of x is simply f of x plus g of x. So f of x is given to be x squared plus 1 and g of x is given to be 3x minus 9. So we can simplify this little further. X squared is x squared, 3x is 3x. We have 1 minus 9, which is negative 8. So this is the sum of these two functions, f and g. Similarly, we can find the difference, f minus g of x. Again, this is f of x minus g of x. So f of x is x squared plus 1, and g of x is 3x minus 9. So we need to subtract this whole thing. So this becomes x squared plus 1 minus 3x plus 9 when you distribute this negative sign. Then we get x squared minus 3x, and then 1 plus 9 is 10. So this is the quotient. So this is the difference between these two functions. Now let's look at product. F times g of x is f of x times g of x. So f of x is x squared plus 1, and g of x is given to be 3x minus 9. Here is another example. So we are given graphs of functions k and l, and we are asked to find k plus l at 0. So this is simply k at 0 plus l at 0. So k at 0 is the y value when x is 0. So x is 0 is here, and y value on the graph of k is over here. So negative 1, 2, 3, negative 3. So k of 0 is negative 3 plus L of 0. For L of 0, we look at the graph of L. When x is 0, y value on the graph of L is negative 7. Negative 7. So this becomes negative 10. So k plus L at 0 is negative 10. Next, we want to find k minus L at negative 2. So this is k at negative 2 minus L at negative 2. So k at negative 2 is when x is negative 2. Over here, k is negative 5. So this part is negative 5 minus L at negative 2. When x is negative 2, L is not defined. So this will be undefined. The graph of L is not given when x is negative 2. That means the whole thing is undefined. Basically, this negative 2 is not in the domain of k minus L. Because negative 2 is not in the domain of L. Next, we want to find k by L at 5. So this will simply be k at 5 divided by L at 5. So k at 5 is 2 divided by L at 5 is negative 2. Because when x is 5, the y value on k is 2. And y value on L is negative 2. So this will be negative 1. Next, we want to find k by L at 6. So let's quickly do that also. So this is k at 6 over L at 6. So k at 6 is 5 and L at 6 looks like a 0. The y value on the graph of L when x is 6 is 0. So this is undefined. We can't divide by 0. So this quotient is undefined at 6. So which again means this is not in domain of this quotient k by L. But here we have L by k at 6. Let's try to evaluate this. So this is L at 6 over k at 6. L at 6 is 0, the y value on the graph of L, and k at 6 is 5, the y value on the graph of k at x equals 6. So 0 over 5 is 0. L by k at 6 is 0. Here we have more examples. So we are given function s of x to be square root of 2x plus 4 and t of x to be x minus 3 over x minus 5. The first one here wants us to find s plus t at 6. So this will simply be s at 6 plus t at 6. And we know s at 6 is square root of 2 times 6 plus 4. We just need to plug in the value of x for this function s, plus t at 6 will be 6 minus 3 over 6 minus 5. So this becomes 2 times 6 is 12 plus 4 is 16 minus 3 over 1. So this is 4 minus 3, which is 1. So this sum at 6 is 1. The sum of these two functions, s and t, at 6 is 1. Next, we want to look at the difference, s minus t at 5. So again, we can simply do s at 5 minus t at 5. So s at 5 is 2 times 5 plus 4 minus t at 5 is 5 minus 3 over 5 minus 5. So this becomes square root of 14 minus 5 minus 3 is 2. 5 minus 5 is 0. So here we have a problem. We are dividing by 0, so which is undefined. Which again means this 5 is not in the domain of difference s minus t. Next, we want to find s by t at 3. So this will be s at 3 over t at 3. S at 3 is simply 2 times 3 plus 4 and its square root. E at 3 is 3 minus 3 over 3 minus 5. So this is square root of 6 plus 4, which is 10. But in the denominator, we get 0 over negative 2. So this equals square root of 10 over 0, which is again undefined. So this 3 is not in the domain of this quotient s over t. So from the examples we just looked at, we need to be very careful about the domain of these combinations of functions. Basically, domain of these combinations, the sum, difference, product, quotient is simply the intersection of the domains of f and g, with exclusion of zeros of g for the quotient. First, we wanted to figure out the domain of s and domain of t. So for domain of s, we need to make sure what we have under the square root is non-negative. So we want to make sure 2x plus 4 is greater than or equal to 0, which means 2x is greater than or equal to negative 4 if you subtract 4 from both sides. And if we divide both sides by 2, we get x is greater than or equal to -2. So this is the domain. I can quickly put it on a number line. If -2 is here, so we include -2, and we look at all the real numbers to the right of -2. So this is the domain for S. Now let's find the domain of T. So for domain of T, since it's a quotient, we need to make sure no value of x gives 0 in the denominator. So we need to make sure that x minus 5 is not 0, which means x is not 5. Because the only way x minus 5 can be 0 is when x is 5. So we can't have x equal to 5. So let's again put this on number line. If I say 5 is somewhere here, we can have all real numbers to the left of 5, to the right of 5, but not 5. So we have a hole over here. And then we can include everything to the right of 5 and everything to the left of 5 except 5. So this number line represents the domain of T. Now, since we said the domains of these three combinations, S plus T, S minus T, and ST, the sum, difference, and product is simply the intersection of these two domains. So which means the common part of these two domains. So if -2 is here, we can't include anything to the left of -2 because the domain of S does not include anything to the left of -2. But we can include -2, which is included in both of these. -2 is here and -2 is here. And we see everything to the right of -2 is taken by S. And everything to the right of -2 is taken by T except 5. So we can include everything to the right of -2 except 5. So this is the domain of these three functions, these three combinations, S plus T, S minus T, and ST. And we can write in the interval form if we like. So -2 to 5 union 5 to infinity is the domain of these three combinations. Now to find the domain of S by T, we just need to make sure there is no value of x that makes T 0. So function T is 0 when x equals 3. So we need to remove that x equals 3 also. So if we draw a number line, we have -2 here, we have 5 here. So we need to remove this point also. So we have another hole over here. We already have a hole here. And we start from -2. So the domain will be this one. All the real numbers to the right of -2 with holes at 3 and 5. Now the last one. So for this one, we need to make sure S is not 0. So for that, we again look at for what value of x is S 0. So this is 0 when x is -2. So we need to remove -2 from the domain. So that means if -2 is here, then we need to have a hole over here. And we already have a hole at 5. So from up here. So this will be the domain for T over S. All right, this is all I have put together in this video. Hope it was helpful. Please subscribe to our channel if you haven't already. Thank you.